Hey guys, in this lesson we're going to be comparing linear, quadratic, and exponential functions. Let's begin by looking at how they're different numerically. When we talk about the values for linear functions, they're going to be changing through either addition or subtraction, so we're looking for this constant rate of change. So when we look at this table, we can see that as we go from -2 to 2, we get plus 4. From 2 to 6, plus 4. 6 to 10, plus 4. 10 to 14, plus 4. So here we have a constant rate of addition by 4. This lets me know that I have a linear function. So when we're adding or subtracting by a constant rate of change, it's linear. When we're talking about quadratic, we're looking for the differences of these differences. And so as I go from 16 to 2, that's minus 14. Then we have minus 4, plus 6, plus 16, plus 26. Now these differences are different. But when we look at the differences of those, the differences of differences, we can see that they are all the same, that they're all plus 10. And so when we look at the differences of differences, if they're all the same, we know that we have a quadratic function. When we talk about exponential, we're looking for the values to change through multiplication or division. So in this table, we can see that as we go from 1/9 to 1/3, that's times 3, times 3, times 3, and times 3. And so we know that we have this growth factor, this common factor of 3. And so this will let us know that we have exponential function. When we're talking about their graphs, we know that the graph for a linear function is a line. For quadratic is this U-shape, this parabola, and for an exponential graph, it's going to be this exponential curve, which starts out slow and then explodes into higher values. When we talk about their equations, we know that linear form has 3 equations: standard form, slope-intercept form, and point-slope form. Slope-intercept form being the most common one that we use for graphing, where m is the slope and b is the y-intercept. For quadratic, we also have 3 forms: standard, vertex, and factored form. Vertex form would be our common one that we use for graphing, where a tells us the size and the direction, h gives us our vertex and our axis of symmetry, and k will give us the y-coordinate for our vertex. And then for exponential, we have y equals a times b to the x, where a is our y-intercept, b is our growth factor, and x is the exponent. Our variable, or our unknown in this case, is our exponent. When we look at their verbal descriptions, we're looking to see for linear, is there addition or subtraction taking place? So here we have skating is $5 to rent the skates and $1 per hour to skate. So we know that they're going to be adding on $1 per hour. So this would tell us that it's linear. For quadratic, we're looking for either vertical motion problems or problems dealing with area. So here we have a ball is thrown upward. So as we throw a ball upward and it comes back down, we get that U shape, that parabola, our vertical motion. So this would let me know that this is quadratic. For exponential, we're looking to see, is there multiplication happening to get from one value to the next? And because a tree frog doubles in size, that's times 2. So we're multiplying by 2 to get to next values. This would tell us that we have exponential function here. Let's take a look at these tables. So we're going to determine if they're linear, quadratic, or exponential. So for my first table, I can see that my values are increasing by 2.5 as I go from each of my values. And so because they're increasing by this constant rate, this would let me know that this table is linear. So when I write the equation for this, it's going to be y equals mx plus b. M is the slope, so in this case it's 2.5. X plus my y-intercept, which in this case is 10, because the y value is 10 when x is 0. When we look at b, we can see that our values are changing by times 6. So they're being changed by a factor of 6. That would be called our growth factor in this case. And so this would be exponential. When we're writing our function for exponential, writing that equation, it's going to be y equals a times b to the x. A would be the y-intercept, so in this case that would be 1. So y equals 1 times b, which is our growth factor, that's 6 to the power of x, which could just be rewritten as y equals 6 to the x power, since 1 times anything is that anything. When we look at this last one, we can see that as we go from 25 to 18, that's minus 7, then minus 5, minus 3, minus 1, plus 1, and we can continue that pattern throughout. All right. And then we can see that the differences of those differences are all positive 2. So this lets me know that my graph is quadratic. Now, when I'm writing the equation for my quadratic, I'm going to put it in vertex form. That's y equals a times x minus h squared plus k. My vertex in this case is 4, 9. I know that this is my vertex because this is where the values repeat. On either side of the vertex, we should have repeating values. And here I have 10 and 10, then 13 and 13, and then 18 and 18. So I know that my vertex is 4, 9. So when I go to write my equation, I'm going to put 4 and 9 in for h and k. A in this case is 1, so x minus 4 squared plus 9, that would be my equation in vertex form. When we look at their graphs, we're looking to see, for this first one, is it a curve, an exponential curve? And in this case it is, so we have an exponential graph for this first one. When we're writing the equation for that, we need to find the y-intercept, and we need to find the growth factor so that we can put it in that a times b to the x. My y-intercept is 2, that's where it starts on the y-axis, so that's 2 times. My growth factor, well, if I look at my y values of 2, 4, and 8, how do I get from each one of those? Well, from 2 to 4, that's times 2. From 4 to 8, that's also times 2. And so my growth factor here would be 2. And so my equation is 2 times 2 to the x. When I look at my second graph, I can tell that that's linear because it's a line. I find my y-intercept, which is 3. I find my slope, which in this case is 2 as I go from up 2 and over 1 to get from my next point. And my equation here would be y equals 2x plus 3 when we write it in mx plus b form. My third graph is quadratic because it gives us this U shape. When I write my equation for this, again, we're going to write it in vertex form. Y equals ax minus h squared plus k. A in this case is going to be 1 again, so I'm just going to not write that piece. And then my vertex is 4, negative 4, so I'm going to plug those into my points here. It's going to be x minus 4 squared minus 4. And so there would be my equation for my quadratic graph. When we're looking at verbal descriptions, again, we're going to determine which ones are linear, quadratic, and exponential. So as we look at this first one, we see a cliff diver jumps from a ledge 88 feet above the ocean with an initial velocity of 12 feet per second. So my velocity here tells me that this is vertical motion, and so we're going to write, we know that this is quadratic. We're going to write our equation for this quadratic graph. We know that all vertical motion equations are going to be y equals negative 16t squared plus vt, v for the velocity, plus h, the initial height. So y equals negative 16t squared plus my velocity, which is 12 feet per second, so 12t, plus my initial height, which is 88. So there would be my equation for this quadratic graph. We have Susanna's tracking the progress of her plant's growth. Today the plant is 5 centimeters high, and she adds Miracle Grow to her plant, which guarantees that it will triple in size each week. Triple lets me know that this is exponential since we're multiplying here. So when I go to write my equation in exponential form, that y equals a times b to the x, I know that my a is my y-intercept, so in this case that's 5 since my initial value is 5, times b, which is my growth factor, which would be 3 since we're tripling in size, 3 to the x. So my equation for this one would be y equals 5 times 3 to the x. When we look at our last one here, we have Linus tracking the progress of her plant's growth. Today her plant is 5 centimeters high, and it grows 1.5 centimeters per day. So this is adding by 1.5 centimeters today. This lets me know that this graph is linear, or this function is linear. So when I go to write my equation, it's y equals the slope, which is 1.5x, plus 5, my initial value. And so these are the differences in linear, quadratic, and exponential graphs.